So, so let's go on with lab 3. In lab 3, we analyze function calls. We first explain how to write C programs with function calls, using function calls. Then we show how to use library functions. First, the standard libraries, such as the math or the stdio, those libraries included with C, and then specific libraries provided by Western Digital for using with RVfpga. So this provides functions such as the printf nexus that you've already used in the Hello World example, which are specific for our core and for our board. And these are provided by Western Digital. And we just have to use the functions. Finally, we explain how the RISC-V calling convention is established. We explain things such as how to call a function with a GAL instruction, to return from a function with a GR instruction, how arguments should be provided to the functions through these registers, or how they return through A0 register. And we explain all this in in an example, and then we ask for some exercises. So this is the example that we include. It's a very simple function. It's a main function which invokes a function that just computes the addition of 3 numbers. This is in C, and this is in RISC-V assembly. So here we explain how to provide the parameters to the function through the registers A0, A1, A2 in this case, how to invoke the function, how the function needs to include a prologue and an epilogue that preserves the registers that are meant to be preserved in RISC-V, how to return from that function, or how to read the return value from A0. We describe all these concepts in this lab. You can view the document if you want to see how we explain all this calling convention from RISC-V. Once we've explained the concepts, we ask the user to resolve several exercises. This is exercise 8 as an example. They have to program this algorithm which will invoke another function, and they have to program this in assembly using the RISC-V calling convention as explained. Okay? Again, as always, the solutions are available if you want to take a look. In Lab 4, we provide a project that mixes C and assembly languages. I'm going to do a demo of this project. The project is an image processing program that receives a color image and returns a grayscale image. Okay? So it performs this transformation, and it uses this C program that we're going to view now. So this program calls a function that performs the transformation. It provides the color image, and it receives back the gray image. After applying this transformation, by calling this other function, which transforms each pixel inside a nested loop, note that this function receives the R, G, and B components of each pixel, and it returns the gray value that corresponds to these components. This function is programmed in assembly, and it's shown here. It uses this equation, and it returns in A0 the result of applying this equation to the R, G, and B components of that pixel. Okay? So this function will receive the R, G, and B components of each pixel and will return the gray value corresponding to that pixel. Is this clear? So let's see a demo of the program. I'll do it. Later you can test it if you want. Well, the board now, we need the board because we're going to execute on the board, but, well, I'll show it, but it doesn't show nothing interesting because the image, we're obtaining it in a file, and we'll open it and view it. So I open the folder that corresponds to this example. It's lab 4, the image processing folder. And you can see here the different files that it contains. This is the main function that I just described in the slides. It has this function color to gray, which receives the color image and returns the gray image by calling this other function, color to gray pixel, which is programmed in assembly. And you can view it in this other file, which includes the assembly program for converting a pixel from color to grayscale. So first of all, we program the board with the bit stream by clicking on upload bit stream, as you've already tested. The board gets programmed, and now we run the program on the board. We execute the program. The program always stops there at the beginning of the main function. We continue, and we pause execution at the end. So the program has been executed, the gray image has been generated, and we can export it. Let me see, by I go into this directory called, okay, let me go there. In the project, image processing project, there's a folder called additional files. This folder, and let me view it here too. Additional files, this one contains the image, the color image that we're transforming. So this is the color image that is an input for the program. Okay, it's a color image. And we're going to generate or to export the grayscale image. So for that, in Platform IO, we just dump, let me see the exact thing that I have. Dump value, this is what I have to write. I'm exporting into this file, grayimage.dat, the gray image generated by the program. Okay, so no, it didn't work. Okay, dump value. After this command, the okay, I'm in the wrong place, sorry. The gray image has been generated. Okay, a file has been exported with the contents of the gray image. It's in a format that I cannot view, but there's a converter to PPM, which I can view. So I convert the image into PPM format by using this application. Copy. And now the image in PPM format should have been, no, it's not, because again, sorry, I'm in the wrong place. I should run this here and yeah. Like, yeah, now it is. Now it's here. I've generated this ppm file, which is the image transformed into grayscale, right? So after this project, which is provided, this is all programmed already in the project, but we ask the students to complete other exercises, such as, first of all, execute the program on a different input image, which we provide, or which they can download from wherever. Also to transform some of the C functions into assembly functions so that they learn how to program a RISC-V assembly function from the C1, and the other way around, so starting from the assembly function, program the C1. This will help them also understand the calling convention of RISC-V. And finally, to program filters, such as a blur filter, and apply it to the color image. Okay? These are exercises that are proposed in the lab and which are, the solutions are available as always. Yes? I'm sorry?
So the input image.
The input? No, that's done inside the program. So,
yeah, that's my question as well. Yeah.
First of all, I didn't stop here, but the program starts by initializing this array with the color image provided from the file. Okay, if you go here, so there's an array which is, okay. These are the RGB values of each.
How did it get into this array?
When you download an image, you can download it. You can view the text of the, and I don't remember. I think I did some script in order to write into that. Yeah,
it's got to be in a struct here.
Yeah, it has to be in that structure.
Okay. Cool.
Well, and these are the first part of labs. So of the 20 labs, talking about programming. So before we start the input-output labs, my suggestion is that you can take a look at these 4 labs and see if you want to repeat or to view the documents, to repeat the demo, to try any other example on your own. Maybe you can for